Assalamualaikum warahmatullahi wabarakatuh and greetings to all Pasum students. Alright, so we meet again in this second last lecture for the hydrocarbon compounds, okay, which is for the alkenes topic. Alright, so in this lecture, we have three learning outcomes that we want to discuss, which is to understand the chemical reaction of alkenes. The first reaction is the addition reaction, consists of hydrogenation, hydrohalogenation, hydration, and the halogenation. And this reaction can undergo via the Markovnikov and also anti-Markovnikov rule, which is the LO number 7 and number 8. Alright, but I skip the LO number 9 and 10, so I add one more LO, which is the last LO, number 11, to understand the oxidation reaction with the KMnO4, K2Cl2O7, and also ozonolysis, because I want you to compare the difference between the addition reaction, which is LO number 6, and also the oxidation reaction, LO number 11. So I combine all these LO. Okay, I skip LO 9 and 10, so that LO we will discuss in the face-to-face lecture tomorrow. Alright, so let's go for the question number 1. So write the molecular formula for the main product from the following reaction. So if you can see here, we have 7 reaction that we want to discuss. Alright, so reaction number 1, 2, 3, and 4 is the addition reaction. Okay, reaction number 5 actually is the addition as well as the oxidation reaction. It is both actually. And the reaction number 6 and 7 are the oxidative cleavage reaction, which is involving the bond breakage between the C double bond C. Alright, so how does this reaction undergoes? Alright, for the addition reaction, it is very easy. You just see that you have H2, so you just add H and H, and you remove the double bond, so it becomes the single bond. You add the H and H. Same goes to Cl2. You remove the double bond, and you just add Cl and Cl to both ends of the C double bond C. Alright, HCl, you just put H and Cl. Alright, so you just remove the double bond. H2O, you add H and OH. Alright, remove the double bond. Alright, that's for the addition reaction, the normal addition reaction. How about the reaction number 5? Okay, reaction number 5 is actually addition of the 2 hydroxyl group. Okay, so you remove this double bond and you add OH and OH to both ends of the C double bond C. Okay, number 6. Okay, the reagent is almost the same as the number 5, okay, which is the KMnO4. But the difference is, the first, number 5, it is dilute KMnO4. Number 6, it is concentrated KMnO4. And number 5, we undergo in room temperature or below, in cold condition. Okay, but number 6, we need to heat. Okay, delta is the heat. Alright, and since we undergo this in basic, so for the end product we acidified. So there are 2 steps. Okay, the first to break the bond, okay, and the second step to acidify the product. Okay, so in this case, you break this bond, and the CH2 will form CO2. Okay, will form CO2. Okay, instead of CH2, okay, it become CO2. The C becomes CO2, while the H become H2O. Okay, there are 2 H over here. Okay, there are two H over here, so it will form H2O. All right, there is one C. Okay, one C, it will form carbon dioxide. So the oxygen is come from the oxidation process. Okay, and for the last reaction, okay, the oxidative cleavage by using the ozone, okay, it's almost the same as number 6, but this one is simpler version. Okay, you have H2C double bond CH2 initially, so you just break the double bond, so you draw like this. All right, H2C double bond, and you break the bond, so it will be double bond CH2. So at the double bond, you just put the oxygen atom. Okay, so you will get two methanol compound. Okay, so in the equation we can write like this. Okay, so the first one, we add H and H to the double bond, so become the alkene, okay, which is ethane. Okay, number 2, we will get the vicinal dihalide. Okay, dihalide. Number 3, we will get haloalkane. Number 4, we will get the alcohol. All right. Number 5, we will get the diol. Okay. Number 6, we get 2 carbon dioxide and 2 water. Okay, we break this bond, so this one will form carbon dioxide and water, as well as this side also carbon dioxide and water. Okay, so we'll get 2 carbon dioxide and 2 water. And the last reaction, you break this bond, you just put O over here, so you will get 2, okay, this is actually 2 methanol, which is the aldehyde. All right. Next question. Okay, this is exactly the same question as the question number 1, but the difference is, okay, this one is the cyclic ring. Okay, and also in this cyclic structure, the C double bond C is the secondary carbon. Over here are the secondary carbon. All right. So what is effect of the secondary carbon? Actually, it do not affect the normal addition reaction. It just affect the oxidative cleavage. All right. And since it is in the cyclic structure, for the addition reaction, it can form cis and trans structure. Okay, cis or trans structure. All right. Okay, let's go one by one. So here, you just put 2 hydrogen over here, so you just reduce the alkene, become the alkene. All right. And when you react with the Cl2, okay, initially you can put the Cl and Cl to both ends of the C double bond C, but the Cl and Cl is actually we add in the trans isomers. Okay, trans isomers. Okay, so we will see later how is the drawing for the product for this reaction. Okay, For the HCl, okay, you just remove this double bond, all right, and put H one side and Cl another side. So H actually you do not write in the structure, isn't it? Okay, so at the end you just only get Cl. Okay, same goes to the number 4. Okay, you put H and OH, so the product will be the OH. Okay, and this one is almost the same as the reaction with the Cl2, but this time the addition of the OH in both sides, okay, in the cis isomer, from the cis isomers, okay, not trans as the reaction with the Cl2. This one is trans, but this one is the cis isomers. Okay, number 6, when you break this bond, okay, actually it do not form two product, okay, but only one product. Okay, you just break the C double bond C, so you still get the molecule, only one molecule, 1, 2, 3, 4, 5. So you 6. Okay, you just draw 6. 1, 2, 3, 4, 5, 6. Okay, at the carbon number 1 you have double bond O. At the carbon number 6 also you have double bond O. Alright, so right now you only has one hydrogen over here. So this hydrogen will be converted to OH. Okay, OH, OH. So you will get the diacid. Okay, diacid. Okay, as for the ozonolysis, it's the same. You break this bond and you open the chain, become almost similar to the oxidative cleavage by the KMnO4. Okay, but this time, okay, I draw it first. 1, 2, 3, 4, 5, 6, double bond O, double bond O. Alright, this time the H over here do not oxidize to OH. It will remain as it is. Alright, remain as it is because the ozonolysis is a milder reagent compared to the hot concentrated KMnO4, which is hot concentrated KMnO4 will oxidize the compound to the highest oxidation state. Alright, so how about the equation? So it's actually like this. Okay, so for the first reaction, you will get the alkene, okay, the cycloalkene. The second, you will get the dihalide, okay, the vicinal dihalide in the trans isomers, okay, trans dihalide. Okay, this one is the haloalkene. Okay, this one is the alcohol. Okay, cyclohexanol. Okay, this one you get the cis diol. Okay, cis diol. And with the hot concentrated KMnO4, okay, hot concentrated KMnO4, it will oxidize to the highest oxidation state, so you will get the diacid over here. And as for the ozonolysis, it will remain as the dial. Okay, dial, which is the aldehyde. Okay. Next question. Okay, still the same reaction. Okay, still the same reaction, but the new challenge over here is this carbon is actually the tertiary carbon, right? The first question is the primary carbon, the second question is the secondary carbon, and the third question is the tertiary carbon. And the second challenge in this question is actually this is no longer the symmetrical alkene. Okay, so you will get the mixture of the product since the reactant is the unsymmetrical alkene. So since in the first reaction, you add the same atom to the both side of the double bond, so it will get just one product. Okay, one product. Okay, same goes to the number 2. Okay, you add the same atom, which is Cl and Cl, so you will also get only one product. But as for the number 3, okay, you can add Cl over here, or you can add Cl over here. Okay, so there are two possibilities of the compound. Okay, depends on which carbon that you add the hydrogen and the chlorine atom. So you will get the mixture of the two product. Okay, same goes to the number 4. Okay, also the mixture of the two product. Number 5, it will be back for one product. Okay, because the addition is the same element, which is the OH and also the OH. Okay, the same group of atom, which is the hydroxyl group. So it will produce only one product. Okay, for the oxidative cleavage, okay, when you cleave over there, okay, you add O over here and O over here. Okay, so you will get the mixture of two product. Okay, number 6. And for the last, it's the same. You just put O, so you will get the mixture of the two product. So what are the products? So let's look in this slide. All right. So the first one, you get only one product, which is the alkene. Okay. Why is just produce one product? Because you add the same atom to the both end of the C double bond C. Okay, which is the hydrogen atom. The same goes to the reaction number 2, the dihalide. Okay, the vicinal dihalide. You add the same atoms, which is the chlorine atoms, to both ends of C double bond C. Therefore, it's only produce one product. As for the number 3, I have told you earlier, you can add the Cl at the carbon on the right or carbon on the left. So you will get the mixture of the two products. Okay, the haloalkene. Same goes to the hydration. Okay, you can add the hydroxyl group in both sides of the C double bond C, so you will get the mixture of two isomers of the alcohols. Okay, for the hydroxylation, okay, this one is the hydroxylation. Hydroxylation, right? This one is the hydration, right? This one is the halogenation. Okay, I forgot to tell earlier about this. Okay, the name of the reaction. This one is the halogenation, and the first one is the hydrogenation. All right. So for the hydroxylation, you just only get one product because you add the same group of atoms, which is the hydroxyl group. Okay. And this is quite interesting. When you break the bond, the C double bond C, by using the concentrated hot KMnO4, and by using the ozonolysis, the product is actually the same. Alright, the product is actually the same. Okay, why they get the same product this time? Because the product is the ketone. And the ketone is the highest oxidation state. Therefore, the hot concentrate KMnO4 cannot undergo further oxidation towards the ketone product. Okay, remember, okay, if you have the C double bond OHH, if you have the methanol, okay, for the ozonolysis, okay, if you produce the methanol for the ozonolysis, therefore, for the hot concentrated KMnO4, you will produce carbon dioxide and water, which is question number 1. Alright. If you have the aldehyde, okay, RC double bond OH, okay, for the ozonolysis, as for the hot concentrated KMnO4, you will produce the carboxylic acid. Alright, because the aldehyde can undergo oxidation to form the carboxylic acid. But in this case, you have the ketone, RC double bond OR. You have no more hydrogen atom attached to C double bond O. Therefore, this is the highest oxidation state. So the product for the ozonolysis and the hot concentrated KMnO4 is exactly the same. Alright. So these 3 questions actually to tell you about the LO number 6 and LO number 11. How about the LO number 7 and LO number 8? Okay, which is Markovnikov and also anti-Markovnikov. Okay, we still do not apply in these 3 questions. So now let's discuss for the question number 4. Okay, so what is the new challenge in this question? Is actually, this is not just an unsymmetrical alkene, but the alkene, the C double bond C has different type of the carbon. Okay, in the question number 1, both carbon are primary carbon. Okay, in the question number 2, both carbon are the secondary carbon. In the question number 3, both carbon are the tertiary carbon. Okay, but in this question, we have 2 types of carbon, which is this carbon is primary carbon, while this carbon is the secondary carbon. Okay, this is where the Markovnikov and anti-Markovnikov will be applied. Okay, according to the Markovnikov, the electrophile, okay, in this case, the electrophile is the H, okay, the hydrogen atom, or it's more accurate when I said it as the proton H+. Okay, the electrophile will be added to the carbon with more hydrogen atom. Okay, so this electrophile, which is the H+, will be added to the carbon with more hydrogen atom. So let's see, the primary carbon has 2 hydrogen atom. Alright, but for the secondary carbon only has 1 hydrogen atom. Therefore, the H from the HCl will be added to the primary carbon. Okay, will be added here, and DCl will be added to the secondary carbon. Alright, so the product will be like this, or maybe I can draw it like this. Okay, so Cl will be at here. because the hydrogen is being added to the first carbon. Okay, but I do not write the hydrogen over here because in the skeletal structure, the hydrogen atom is hidden. All right. Direction number 2. Okay, for direction number 2, it's the same reagent, which is the HCl, but in this time, we put the peroxide. Okay, we put the peroxide. So, the peroxide will cause the reaction will follow the anti-Markovnikov. Okay, this one is the Markovnikov. Okay, but the presence of the peroxide will cause the reaction will follow the anti-Markovnikov. Therefore, the Cl will be added to the last carbon, okay, or the first carbon. All right. Okay. The question number 3 or direction number 3 is similar to the first reaction, which is the hydrogenation. Okay. This is the halogenation. I'm sorry. Right. So this is the hydration. And as for the hydration, we will add the H and OH. So H will be put in the first carbon, okay, H over here, while the OH will be inserted to the second carbon. So you will get the 2-butanol. Alright, okay, this is the same lah, okay, if I draw like this. Okay, sama je tu. Alright, next, oxidative cleavage. Okay, actually, only these 3 reaction applies the Markovnikov and anti-Markovnikov, which is to achieve the LO number 7 and also LO number 8. Okay, but I still put the oxidative cleavage in this question so that you can see, you can learn more about the oxidative cleavage and see the difference between the oxidative cleavage by using the hot concentrated KMnO4 and also by using the ozonolysis reagent. Alright, so look at the direction number 4. So you break the bond over there. So here we have 1 hydrogen atom and here you have 2 hydrogen atom. Okay, so remember, okay, we go for the ozonolysis first because it is easier. Okay, ozonolysis, okay, we have 1 hydrogen here and 2 hydrogen over here. Okay, you break this bond. So the first product on the left, you will get this zigzag double bond OH. Okay, you just break the bond and put the O over there and O over here. And as for the product from the carbon on the right, so you will get O double bond H. Okay, so you will get this one is the aldehyde. And this one is also the aldehyde actually. But specifically this one is the methanol. Alright. So remember I told you earlier, if you have the aldehyde, the H over here will oxidize, further oxidation to become OH, which is formation of the carboxylic acid. Okay, so this is the carboxylic acid. And as for the methanol, it's very special because the C double bond O, okay, will become the carbon dioxide, and the 2H over here will become the water. So the products are carboxylic acid plus the carbon dioxide plus the water molecule. Okay, this is shown in this slide. Okay, so the first one, the normal halogenation follow the Markovnikov rule. So H being added to the first carbon and Cl to the second carbon, so you get this haloalkane. Okay, but for the second reaction, since we have the peroxide over here, and this reaction will undergo anti-Markovnikov addition. So the Cl will be added to the first carbon, while the H actually will is added to the second carbon. Okay, sebenarnya dia letak kat situ, kat sini, but we do not show in the skeleton structure. Sebenarnya ada lah dekat situ. Alright. The third reaction, the hydration reaction, it is similar to the first reaction. So H at the carbon number 1 and OH at the carbon number 2. So you will get this butane to all. Okay, a type of alcohol. Okay, and for the reaction number 4, so you will get carboxylic acid, okay, carbon dioxide, and also water molecule. Okay, water molecule missing. And the reaction number 5, you will get the aldehyde. So this is actually 1, 2, 3, the propanol and methanol. Okay, so the propanol oxidized can be oxidized to this carboxylic is the propanoic acid. Okay, but the methanol, okay, oxidized to the carbon dioxide and water molecule. Okay, the last question. Okay, similar to the question number 4, but the difference is this one is the combination of the secondary and the tertiary carbon. Okay, secondary and the tertiary carbon. So same as previous. According to the Markovnikov rule, the H will be added to the carbon which have more H. So the secondary carbon still has 1 hydrogen atom, but the tertiary carbon no more hydrogen atom. Therefore, the H will be added to the secondary carbon. Okay, so this H will be added over here. Okay, and the Cl will be added here. So you will get Cl over here. And as for the anti-Markovnikov, biasalah dia terbalik. Alright, so you will get Cl over here. Okay, the hydration, same as the hydrohalogenation according to the Markovnikov rule. So the product will be, okay, salah lukis. The product will be like this. So you just add OH over here. The oxidative cleavage by using hot concentrated KMnO4, as usual, it is easier for us to write the equation for the ozonolysis first. So ozonolysis, you have 1 hydrogen over here. So you will get the aldehyde. H double bond O. Alright. Plus on the other side, on this side, okay, you have no hydrogen atom, so you will get the ketone. Okay, so this is the aldehyde and the ketone. Okay, as I told you earlier, the aldehyde will further oxidation, will undergo further oxidation to produce the carboxylic acid if we use the hot concentrated KMnO4. Okay, but for the ketone, it will remain as it is. So, sama lah. Okay, the product is exactly the same. Okay, these two are the same, but aldehyde oxidized to the carboxylic acid. Alright, so these are the answers. Okay, as we discussed earlier, so according to Markovnikov, H will be added here. Okay, so that we do not show the H over here. Alright, so we just show the insertion of the Cl at the tertiary carbon. Alright, anti-Markovnikov, so the Cl is being added to the secondary carbon. The hydration, the hydroxyl group added to the tertiary carbon. Okay, hot concentrated KMnO4 oxidative cleavage produce the carboxylic acid and the ketone, while the ozonolysis will produce the aldehyde and ketone. Alright. Okay, that's all for this lecture. Okay, I hope you understand about the reaction, so that in face-to-face lecture tomorrow, we can discuss about the mechanism of the Markovnikov. Kenapa dia follow the Markovnikov? Actually, there are the reason behind the Markovnikov rule. Okay, actually, if you read my lecture notes, okay, that I have distributed to you earlier, okay, everything has been explained. Okay, termasuklah the mechanism of the halogenation, the mechanism for the anti-Markovnikov. But for the halogenation and anti-Markovnikov, it's just for your understanding, but it is actually not in your syllabus. Okay, their mechanism is not in your syllabus, but the reaction is in your syllabus. So you just need to know the reaction, okay, not the mechanism. But the mechanism, the important mechanism for you about this reaction is just the Markovnikov, okay, Markovnikov rule. All right, see you in the lecture tomorrow. Thank you.